Hi, good morning. Good morning, everyone. Now it's 12:54. So good afternoon, everyone. So now I will discuss hot the hot question which come out from the past year. So as you know that this chapter 5 vector will come in our PSPM 2022. So I apologize to you all. So because now I'm in my college and it's hard to find a quiet place to record. So it will be noisy a little bit. Yeah, got the cat sound. The cat is meow meow, meow meowing. So okay, so I just straight away go to the question. So I will prepare now. Today I prepare the eight question, which I think is some is not very hard lah, but it has some special technique to do. So let's start with question one. So given that A, B, and R. This question I got discussed it before in at chapter 5.1 or 5.2. Yeah, I remember I have discussed it. Okay, never mind. So I just explain one more time. Given that A, B, and R are three vectors, this lambda is the scalar. So it has two information. The A times R equals to B plus lambda A. Dot product is 2. So by using the property of this scalar product, where? Here. Is it here? Properties of vector. Oh, sorry, it's the properties of vector product. Is this last? Oh yeah, I have discussed it at this, maybe in this part. So using the properties of this vector product, so show that R equals to this. Okay, and the B just determine the vector R and the scalar lambda. Okay, let's go. So they give the property B cross product. So cross product it give A times R. So I sub this A times R into this B times C, and the dot product AC. So AC I sub in this AR. Okay, before that, you need to know that in this question, I will use this A equals to A also, the B equals to A also. So this A equals to B. And this C will be R. The C will be R. This is what I sub in my, uh, yeah. This is what I sub in this property. So this A equals to B, so it will be AA. So AA will be A squared. B plus lambda A. This A dot R equals to 2. So the properties of vector product A times B equals to A times lambda A. So A times lambda A can take out the lambda. So become A times A. A times A will become the 0. This, okay, so just continue. Continue. So I take out the R's because I want to find R. So will be 2A minus A times B. So I take away the A squared. So R will become this formula shown here. So B determine the vector and the scalar. So for this I will do the vector R first, find the vector R first, because only I find the vector R I can only do this scalar. Okay, for this vector r, this vector r, so you can see I need to find this a times b equals to what, a squared equals to what, and 2a equals to what. So I need to find three things and then combine. So a times b, I use the matrix form. So will be negative 5i minus 5j minus 5k. And the a squared will be 6. No need to put the third. So the 2a will be 2i plus 2j minus 4k. So r, I combine all it. So I will get 7i plus 7j plus k divided by 6. So I can separate them. This is easier to see. Okay, so now I find the r. So I need to find the lambda. So a times r equals a times r equals to b plus lambda a. So next I need to find this a. I write where a times r equals to b plus lambda a. So I need to find the a times r come out first. So the a times r, so I will get this 5 per 2i minus 5 per 2j. So b plus lambda a, for me, I take the lambda to left hand side first. So the a equals to I plus j minus 2k. So this a times r minus b. So multiply all the lambda inside. So compare the coefficient. Simply take coefficient or I. I take I. We want to compare j or k also can. Because the lambda are the same, which is 1 per 2. You see the k also, negative 2 lambda equals to negative 1. So will be negative 1 divided by negative 2 equals to 1 per 2. It's same. So the answer will be scalar equals to 1 per 2. And the vector r will be this. Okay. So we go to the question 2. So A, B, and C are 3 points in the three-dimensional space. This is quite simple. It just tricky and just test you remember this the area of the minor sector or not. Okay, let's go. So if O is the origin, write down the position vectors of the points A, B, and C. Okay, so OA, OB, OC, the position vectors is easy. You just put the ij and k inside. So find the vector equation of straight line AC. So straight line AC is okay. Just use OC minus OA. So I get 2i plus j minus 3k. So because it asks the form e plus lambda q, so you need to put the A, the, the OA, the A is the OA, which come out first because the A come out first, so I use this A as the fixed point. A plus lambda. Lambda in this is the direction vector. So the direction vector is AC. So I sub the AC as inside. I also can write it as small letter c or small letter a. So here's the answer. It's simple also. Okay, find the vector equation of a plane pass through point B perpendicular to OB. Okay. I written it pass because it passed through B perpendicular to OB also, so it's you see a line and the place like that. Okay, so perpendicular to OB, so I need to find the normal is OB and the dot product between the fixed point B and the normal vector n will be 14. will be 14. So in vector equation, so vector equation got R, so I put this R. R dot 2i plus j plus 3k equals 14. So last, there's a circle with center O pass through the points A and B. So calculate the area of minus sector OAB. Okay, I draw it here. Find the minus sector of OAB. Simple, you need to find the and to find the angle, so you need to find the dot product and the magnitude. And then you get this theta, but this theta is special because you need to find the area of minus sector. So as the area of minus sector will be 1 per 2 r square theta. From secondary school, we learned this. So the theta must in radian form, so 1.2056 radian. So I can get the area. Okay, the radius is here. Because I find the OB and OA, the magnitude is 14, right? So it will be the radius. And the angle, so I will get 8.44 units square. Just like that. Compared to the other question I prepared, so this is more easy. I think this is the easiest. You just tricky that does you still remember this area of minus sector or not? So that's why I put this question into the host question. Okay, for the question 3. P, Q, and R in the 3 points in space, such as PQ is A and PR is B. So given that A equals to this, B equals to this, so find the angle of PQR. PQR. Okay. So go. I draw the triangle. So I need to find the cross product between A and B. First, in order to find the area. So the cross product of A and B, is 6i plus 2j plus 5k, and the PQR is 1 over 2 times the magnitude. So 1 over 2 are 65. This is simple. You just remember that why times A, why we need to find the triangle, we need to times this A times B, because remember that the parallel, remember this the parallelogram is the area is the magnitude of this length times this length or not. So triangle will be the half of parallelogram, so need to 1 per 2. So don't be confused that A and B is the normal vector. So I times the A and B, I will go outside. I will get the answer is go outside. It's special a bit. Okay. So next I obtain the parametric equation of the line pass through R and parallel to A. So R will be the fixed point and A is parallel, the vector direction vector. So parametric form, I just write this R to xi plus yj plus zk, and I compare the coefficient of I, j, and k, so I will get x, y, and z. It's simple. Okay, For this question, the trickier part is the C. Because maybe some of you will be confused that, oh, so many so many letter I confused, I become blurred. So if U equals to this, evaluate U dot V. So interpret the geometrical relationship between U and V. Okay. So for this question, just U dot this V. Okay. Do like do like factorize it. So A dot together, this dot together, this dot together, this dot together, like factorizing it. So AA will be A square, BB will be B square. So this ABBA equals to ABAB. This minus this will be 0. So BB will be B square. So A dot A will be A square. So for scalar form, for the properties of scalar product, so b square a square can be written as this a square b square also. So minus it, this minus this will be 0. So the dot product is 0, so the u is perpendicular to v. Just like this. Okay, so given the point and the straight line and the plane, so need to find the acute angle between the straight line and the plane, and find the point intersection and the Cartesian equation. Okay, let's go. This question is tricky at the question A, because when you find the direction vector 3i minus 2j plus 4k and the normal 2i plus 2j plus k, and you find the dot product and the magnitude, and you get the angle will be exceed 90 degree. So how to settle this question? Because the question asks for acute angle. It's exceed 90 degrees. So for this question, I have draw the plane. You imagine that this is 3D. This is the 3D. The place lie on the surface, and the L is it penetrates through this plane. So you can see if like this, the angle will be exceed 90 degree. So the acute angle will ask for acute angle. So you need to, for me, I rotate, I flip, I flip it. See, I flip it. Or no need to flip it. Just take the angle at here. The acute angle at here. Okay. So you can see that the sum of the theta plus alpha will be 180. So you need to find, in order to find the theta, so you need to use 180 to minus the alpha. So we'll get 7.1 degree. Just like that. Okay, the B, the point intersection of straight. Okay, just easy to, you need to write the line in the parametric form and the plane in the Cartesian form. So sub the x, y, and z into it. So I will get the t equals to -3. So I will get sub this t into x, y, z. So I will get x equals to 8, y equals to negative 8, y equals to 6, and z equals to negative 15. So the intersection point will be this. So see the Cartesian equation of a plane containing the point P and the straight line L. Okay, for this you need to find a fixed point and a normal vector. The fixed point will be the straight line L from here will, will be 1, 0, negative 3. So I name it as A, name the fixed point as A. So I need to find the direction vector of AP. So I will get negative 7i plus 3j plus k. And I need to find the normal. Normal will be the V. V is the direction of the length. Here. The direction vector of the length. V times this AP will be this, go upwards. The normal. Use the matrix form, I will get negative 14i, negative 14i minus 31j minus 5k. So in order to find the equation of plane, so I use the r dot n equals to a dot n. So because it asks for the Cartesian form, right? The Cartesian form, right? So I multiply negative 14x minus 31y minus 5z equals to 1. Yeah. The B and C is basic. It's just tricky, a little bit tricky about the A. So for question left, for this show that in the triangle, I also explained before in chapter 5.3, but because I think that this one of the hot questions, so I explain one more time at here. Okay. So if A equals to this and B equals to this, so show that the cross product square equals to magnitude square minus dot square. Okay, because it gives the A and the B, and because for easier to find, just straight away to sub this value of A square B square ini, for more easier to sub this value of this, so I need to find each come out. Find the value of each thing. This A square, this B square, this dot product square, all this need to find out. And then compare it. So I will get A square. No need the third form. Straight away get 6. The B square equals to 22. So the dot product will be negative 7. So for the right hand side, here's the right hand side. So total up will be 83. Next, I find the left hand side. The cross product, 3i minus 5j minus 7k. So the square of the magnitude cross product, no need this third form, this no need. I also get 83. This left hand side also 83. So to summarize it, so the left hand side equals to right hand side equals to 83. So I prove that this the cross product square equals to magnitude square minus this dot square. Okay, so B in a triangle, it gives you the AB and AC. So Use the result in A, show that the area of triangle is this when P equals to A, Q equals to B. So I just sub is A as P and Q as the B as Q. So we know that the triangle, the area of triangle, the formula will be half the cross product. So I can just take out the 3 because just multiply, is it? Just multiply, all is multiplied. So I just can take out the 3 and take out the 4. So this will be 12 with half, so it will be 6. 6 with the magnitude of cross product, so will be the third form of this which is shown. So because P equals to A, Q is equals to B, so I sub back A, B, A, B. So I look back this A, the each side equals to 83. So when it's assert it, so will be 83 times 6 units. Or you want to write solve the third into decimal form so can? Here's the answer. Okay. 3 questions left. So if the line, okay, for this I think is considered the hardest because the B here is make many students confusing. So if the line is parallel to the plane, so show that 3a minus b plus 2c equals to 0. So hence find the equation of plane pass through this point. Because it's complicated, so I draw it in the diagram. The line is parallel to the plane, you can see, and is perpendicular to the normal. So V is perpendicular to N. So V dot N equals 0. So the normal is AI plus BJ plus CK. So I get 3A minus B plus 2C. Just multiply it, equal to 0. It's shown. So to find the equation of plane that pass through the point. So x equal to 1, y equals to 1, z equals to 0. So I sub this x, y, z inside. So I get b equals to negative a. I sub again. So c equals to negative 2a. So I will get the pi equals to ax minus ay minus 2az. So I divide the a, so x minus y minus 2z equals to 0. Compared to b, a is more simple. So v, b, b. Given the line in Cartesian form, not Cartesian form, this the parametric form, the second plane and the point, fixed point. So if the line is perpendicular to the plane, so we will conclude that the line is parallel to the normal of the plane. So show this equation come out. For this, the the question give lambdas 2. Let me change it to vector vector 2, this vector 2 to easier to do it. Okay. Okay. For this question, I also change it to vector 2. Because to get the lambda 2, you cannot do anything. Okay. So we know that the V2 is parallel to the normal. 2 is parallel to the normal. So I need to find the lambda in order to get this V2 come out, I need to take out the negative come out. So what I need to take out, so I will show it at question B2. So let me just show it. So the V2 equals to negative lambda. Okay, for this, find one example of the equation that satisfies this B1. Okay, now I explain why I get this negative come out. Because I want to get the lambda as 1. I get the lambda as 1, so I easier to do the back one. So when the lambda is 1, so the V1 will be negative 2, V2 will be negative 1, this negative 1 equals to negative 1, so V3 equals to 3. Okay. It's more complicated. I think this is the hardest because it's the hardest to be understand this. So you can get this question 2x plus y minus 3z equals to 0. So for the x equals to 1, z equals to 0, you can just simply take a point, just satisfy this plane. Just simply a point which can satisfy this, which are available in this plane. So I get x equals to 1, z equals to 0. So I get y equals to negative 2. So the fixed point will be 1, negative 2, 0. So one equation of the line satisfied this B1 is x equals x equals to 1 minus 2t, y equals to negative 2 minus t, z equals to 3t. Yeah. I hope this don't come out in our PSPM. This is hard. Yeah. Especially this B2. Okay. This question 7. The line, the two lines pass through A and B direction of this respectively. So state the equation of this line 1 and line 2 in the vector form. So calculate the acute angle between them. And second, find the Cartesian equation of the plane. And third is determine this line is parallel to the plane or not. Okay. The question is tricky at just do it first. Okay. So I need to get the V1 and V2 come out. V1 equals to this, V2 equals to this. So to write it is the vector form, so the first line equals to this A plus TV1, this, and the second line is B plus TV2. It's simple, but it is simple. So next I need to find the acute angle between them. So I find the dot product will be 4, magnitude of vector 1 will be cert 21, magnitude of vector 2 will be cert 38. So the angle will be across them become 81.9 degree. Okay. Find the Cartesian equation of the plane contain this line and the point C. Okay, I draw it here. Contain the line and the point C. So I need to get the vector AC. I need to get the vector of AC. So it will be 2i plus 3j plus 2k, and find the normal between the first line and the AC. So I will get the normal. By using matrix form, I will get negative 2i minus 6j plus 11k. So use back this Rn equals to An. So will be 2x, negative 2x minus 6y plus 11z equals to 61. Okay, for C. I show this question because I want to show this C. How to prove that the line, this second line is parallel or not. Okay, sorry, it's not noisy now. So the n. Okay, sorry. So okay, got people scared about the cat. So to prove that this V2 is parallel to the plane or not, so I need to find this n turn out. The n and the V2, is it perpendicular? So the dot product between the V2 and n, so I will get 0. So V2 is perpendicular to the normal vector. So the line is parallel to the plane. Just simple how to show it. But maybe many people don't know how to prove is it parallel or not. So I explain the question. Okay. Finally, we go to the last question. Okay, this is very long. This is a long question. Not so hard, but this is long. So H and K are two parallel planes. So point P on the plane H, point Q on the K. To avoid to be confused, I draw it H and K. PR is on the H, QS is on the K. PR and QS are normals of the planes. So state the PR. So A is this question is difficult. That is long. The question is long. So find PR. So just vector R minus vector V. So I will get I plus 4j minus 7k. So find, okay, exhausting because this is long. Find the vector equation of the line pass through the point Q and parallel to PR. Just now we have find the PR, so it's not hard. So the fixed point will be this Q. So R goes to A plus dV. So sub the A, sub the V. So here's the answer. So the second, find the Cartesian equation of plane K. Okay. So you get the normal because the PR and QS are parallel. Because yeah, PR the QS is parallel. We know from B1. So for the normal, we just take the PR, I plus 4j minus 7k. So the fixed point I get from the Q, 2, 3, negative 1. Rn equals to An. So x plus 4y minus 7z equals to 21. Okay, the B3, the acute angle between the intersection of plane K and another plane with equation this. Okay. So this is find the angle between two planes. So the normal of plane K is I plus 4j minus 7k. This is the normal of another plane. So I get the dot product, negative 15, magnitude, cert 66 and cert 14 respectively. Because I use alpha, because when you see I get the dot product is negative, so I need to let it as alpha, cannot let it as the theta. because the two planes, sorry, I just try to, yeah, here is the 180. When you find this is the exit 19, so you need to find the acute angle, so you add here. Imagine that this is a 3D. This question need to use the imagination, or you just use the theory. When you see the product is negative, you just straight away know that is the obtuse angle. So you need to use 180 to minus the obtuse angle, so you will get this acute angle 60/4. Okay, the last. Finally, so describe this qx equals to 3pr in theoretical form. So determine the coordinates of point S. Okay, so qs equals to 3pr. So in theoretical form, the qs and 3r are parallel, and the magnitude of qs is 3 times the magnitude of pr. Just like that. So to find the coordinates of S, so I use this formula. Just like this formula. I need to find the QS come out first. QX, I don't know the S, so X equal X minus 2, 1 minus 3, Z plus 1. So 3PR will be 3I plus 12J minus 21K. So I use by this 2X equals to 3PR. I compare the coefficient of ij and k. So I'll get the x minus 2 equals to 3, x equals to 5, y minus 3 equals to 12, y equals to 15, z plus y equals to negative 21, so z equals to negative 22. So the coordinate of x will be 5, 15, negative 22. Actually, this question is not hard, but it's because it's too long. Because it's too long, so it will look like it's hard. Because you know lah, some people don't like to see many words. Okay, so here is the end of chapter 5. So in next video I will explain, I will go to the chapter 6. Okay, so thank you for watching. Bye.